Hello, everybody, and we are on lesson 5.1 in your textbook. It's on page 283. Make sure you take all the notes that I'm writing down and show them to me for your points. Before we start, I want to show you something about exponents and powers. So this is a table of powers and exponents. So this right here is called a power. Now the base is the one here, this 2 is the base, and the x, do you see how it's a little bit higher? It's not 2x, it's 2 to the power of x. This is called an exponential expression. In other words, the variable x is the exponent, yeah? It can be any variable. It can be y, it can be d, e, whatever letter you want to come up with, but it's positioned higher, and it tells us there's a number hidden behind this variable that tells us how often we multiply the base by itself. So base and exponents together make a power, yeah, or exponential expression. So let's look at 2 to the power of 4 is 16 because the 4 tells us we're multiplying 2 4 times. 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16. 2 to the power of 3 is 8 because it's 2 times 2 times 2. 2 to the power of 2 is 4 because it's 2 times 2. Now here's something interesting. 2 to the power of 1 is the number itself. So any power of 1 is just the same number. It's understood that it's just the base, yeah? So you can write any number. If I want to write a number, let's say 90, if I want to make it look different, I'll just write it power of 1 because it's still 90. It's 90 times 1, really, that's what that means. 2 to the power of 0 is interesting also. So these two I need you to pay attention to. Anything to the power of 0 is always 1. Okay, now we're coming to the negative exponents, and this is really what the lesson is on about. Notice the base 2 is raised to a negative 1. Whenever you have a negative exponent, your answer is actually a fraction. It's small. It makes the answer smaller. Yeah, so it's 1/2. And then 2 to the power of negative 2. So we have a negative exponent. It makes our answer smaller because it's really a fraction. It's 1/4. A way to look at it is 2 squared. 1 divided by 2 squared, which is 1 divided by 4. Over here we have 10 to the power of 4. The power of 4, when it's base 10, you just add the zeros. So you have 4 zeros after the 1. 1, 2, 3, 4. Yeah. Power of 3, you add 3 zeros to the 1. Power of 2, 2 zeros. Power of 1, again, makes it the same. Power of 0 is always, the answer is always 1. A negative exponent makes it into a fraction, and then the same here. So today's lesson is about negative exponents, but it's not about negative bases. So the base being negative is not affected by this negative exponent. Okay, so it's the negative exponent that makes it that goes to the bottom of the fraction, and it becomes a positive exponent. That would be negative 100. Now, if I put it in parentheses, it would be positive 100 because I'm squaring a negative. So the parentheses make a big difference when you square a number, okay? All right, so this little chart gives you an overview of what we're going to be doing in this lesson. So let's go back to our page 5.10 and negative exponents. And what we're learning, objective, is to simplify expressions involving 0 and negative exponents. Let's go straight to our, excuse me, let's go straight to our chart. The examples I want you to highlight, anything to the power of 0 is always 1, no matter what the base is. So this is kind of a general explanation. A being a number, a non-zero number, raised to the power of 0 is 1. If we take a negative number and raise it to the power of 0, it's still 1. If we take a decimal number and raise it to the power of 0, it's still 1. The answer is always 1. Yeah. For every, so this is the negative exponent, 7 to the power of -3. In our answers, we always want to change the negative exponent to a positive exponent. And how do you do that? You write it over 1 and you put it in the bottom of a fraction. So the move of taking it from the top to the bottom of a fraction, you're going to get a positive exponent. It's only the exponent that becomes positive, not the base. Notice how the base is negative and it stays negative. It's the exponent. Let me make that bigger. Okay, now it won't go. There we go. It's the exponent that becomes positive. You see, -2 becomes +2. The base, -5, stays negative. Right? So if I want to simplify that more, I can say -5 squared is +25. Why? Because -5 times -5 is +25. But remember, we're writing it under a 1, in the bottom of the fraction. So negative exponents make your answer smaller because 1/25 is less than 1. So down here, I want to show you, the only thing I want to show you is that this is not true. 0 raised to the power of 0. Remember, anything to the power of 0 is 1. Anything to the power of 0, any number raised to the power of 0 is 1. However, 0 doesn't work. It's called undefined, okay? So 0 to the power of 0 is actually the only exception where our answer is 0, okay? All right, let's go to the next page. And we're starting, where am I here, guys? Oh. Okay, we're on page 284, problem 1, simplifying powers. We're gonna go through this really quick. What are we seeing on the side of the page? Your think box. Can you use a 0 as an exponent when the base is a negative number? Yes, I showed you that on the previous page. It's okay. Like this right here, we have the base, a negative, raised to the power of 0. The answer is always 1. Okay, anything raised to the power of 0, answer is always 1. You don't have to. Negative exponents we make positive by putting it in the bottom of a fraction. Now my negative exponent becomes +3. Do not keep writing it as a negative. It's going to be a +3, which is we only want positive exponents. And then 4 to the power of 3, try it in your calculator, is 64. So it's 1/64. 3 to the power of -2, we don't want negative exponents. We make it positive by putting it in the bottom of a fraction. Now the -2 exponent is positive. And that's 3 squared is 9. 6 to the power of -1, we don't want a negative exponent. It becomes positive, which is the same as 1/6. I just remembered, I want to show you something else on the first page you need to add in your notes. So let's go back to that first page. And down here, there's another case. I'm going to put it right here. There's another case that might happen is if you have a negative exponent in the bottom of a fraction. So if it's in the bottom, you can't put it in the bottom. It's already there in the bottom of a fraction, and it has a negative exponent. You just move it to the top. So, and you multiply with whatever is already up there. Now it becomes positive. When you move it to the top, we don't have anything left on the bottom of the fraction. So that goes away. We don't need anything in the bottom. We do need something on the top when that case arises, but not on the bottom. So 3 squared is 9. 9 times 1 is 9. Yeah, so either moving it to the top or to the bottom of a fraction makes our exponent positive. Back to our work page. -4 is our base, so that's okay. The base can be a negative. This is okay. Don't change that. It's the exponent we want to change, right? The exponent cannot be negative. So I'm going to circle it. Write it in the bottom of a fraction. Do not change the base. Yeah, so that's 1 over -4 quantity squared is 16. So I'm going to make a little notation. Base can be negative. Do not change. Only change exponent. To positive. We don't need negative exponents. We don't like negative exponents in math, okay? All right, next page. What do I have down here? Oh, let's try this one. Number 1, we're still on the same page. 1 divided by 2 to the power of 0. If you paid attention, you know that 2 to the power of 0 is 1. 1 divided by 1 is 1. So that kind of looks like that. I know I'm moving fast because this is a big lesson. Now we're on page 285, an algebraic expression. Algebraic expression means you got variables involved. Do you see? X, N, yeah? It has variables, not just numbers. Sometimes you have variables combined with numbers, but is in simplest form. We always want it in simplest form when the powers with a variable base are written with only positive exponents. Positive exponents is the clue here. We don't want any negative exponents. What is the simplified? Let's look at the think. Think, which part of the expression do you need to rewrite? Only the part with a negative exponent. Everything else stays. Okay, so you got to look at which part has a negative exponent, which power. On number 2a here, there's nothing to, there's only that one part, so we're going to write it over 1 and make it positive 9. So that's that. B, same thing. You have, okay, so it's on the bottom. Notice it's in the bottom already. So what am I doing? I'm going to move it to the top. And that makes it just positive n to the third positive exponent. The 1 on the top you don't need it. It's really reads as 1 times n third, because whenever I move it to the top, I'm going to multiply it with whatever is already there. But if it's a 1, it doesn't change anything. So therefore, I don't need to write it. Multiplying by 1 doesn't change anything. Oh, look at this one, C. We got more parts. We got a 4, and we got a B, and we got that C. Which part has the negative exponent? It's just this little part. The 4 doesn't, and the B doesn't. So with that part, we leave alone. So start out by making a fraction and decide what stays on top, the 4 and the B, because they're not changed. The C goes to the bottom and becomes a positive 3, the exponent. Look on D, what do we have? The 2 does not have a negative exponent. Yeah, it doesn't have any exponent, neither positive. Well, it has a 1. If you remember, any number has a power of 1, but it's positive. The one that is a negative exponent is this thing here. That needs to be moved to the top. Make a fraction, start out with a fraction bar, leave the 2, and you're going to multiply by a to the power of 3. Now, remember, if you move it to the top, there's nothing left on the bottom. Really, there's a 1 if you think about it. But the 1 isn't needed, not in the denominator. So I'm going to rewrite that to make it sharper looking. I'm going to say 2a cubed. That's it. That looks much better. We don't need that fraction. We don't need 1 in the denominator, but we do need it in the numerator, which is kind of weird, but that's how it is. All right, let's look. This is a good case, like why do I need it in the numerator? The power of -5, that exponent needs to go to the bottom. Well, if I move it to the bottom, I'm going to multiply it with what's already there, which is m squared, and now my 5 is positive. But what's left on the top has to be a 1 because this is a small number, yeah? And so that 1 makes it a small, the expression, the value, if I put in numbers for n and m, will make it a small number. So therefore, that 1 is important when it's in the numerator. So I'll write important, I'm important. But here it's not important. This one here, nope, doesn't need to be there. And let's go to the bottom. We have a couple more. So the part that needs to be moved is the negative exponent. The d to the 7 stays. Make a fraction. Always start out with a fraction. Think, what do I need to move? It's this one to the bottom, right? So that would go down here. And it's a +5. Sometimes I see students, they make a mistake. They move it and yet keep it negative. The purpose of moving it is to make the power positive, is the exercise. And you don't want to leave it negative. That would be wrong, okay? We're not doing that one. And then let's move on to the next page. And I'm going to skip the ones that have where you evaluate, because you need to plug in the numbers for N and W. First you simplify, then you plug in the numbers. I'm going to skip that part. The lesson is very lengthy. I want to get to these word problems. We're on page 287. Doesn't show it. Yeah, here it is. Nope. Cut that off. 287, very much on top, using an exponential expression. So this is where the fun starts. This is why these things are so important. A population of insects triples times 3. Tripling means times 3 every week. This is our unit. We're counting by weeks, okay? The number of insects is modeled by the expression 5,400 times 3 to the power of W. So this is an exponential expression because our exponent is a variable, yeah, 3 to the power of W, where W is the number of weeks after the population was measured. Evaluate the expression for W is -2, W is 0, and W is 1. What does each value represent in this situation? Okay, I'm going to take a second. So what we're going to do, guys, is we're making a t-table to find our answers. And the function or the rule I'm putting on top, 5,400. You can also use parentheses times 3 to the power of W. Notice the W is a little higher. That's my exponents. And this times and the parentheses mean the same thing, okay? So we're going to put in the numbers -2. By the way, this is my input would be weeks. So I'll call it W, and my output or the answer is the number of insects that we have after a certain amount of weeks. So what does -2 weeks mean? It means 2 weeks ago. 0 means now. And then 1 means in a week. So let's write that down. 2 weeks ago from today. This means today or now, which is always your starting point. This is an important point when we have 0. That's always, let's make it green. This is very super important. Starting point. And then 1 means in 1 week from now. And what we're looking for is the population or the number of insects within this time frame. How many insects were there 2 weeks ago? How many insects are there now, today? How many insects will there be in 1 week from now? So this is kind of what we're doing, okay? So we got to plug in the numbers for W. So I'm taking the rule and on my calculator, 5,400 times 3, W is -2. So I'm plugging that in for W. And remember, the power comes first, and that would mean it's 5,400 times 1 over 3 squared is 9. Yeah, because I'm making my negative exponent positive. And that, by the way, if you don't like multiplying by this fraction, you just go 5,400 divided by 9. And when you do the division, you'll get 600. So what that means is that there were 600 insects 2 weeks ago. So you counted them, all right? Now let's plug in 0. Times 3. This is by the way, this is called a growth factor. Remember the word growth factor. Tripling. Right here, okay? So we're having to the power of 0. Now remember, anything to the power of 0 is 1, right? So I'm just going to replace that with a 1. So it's 5,400 times 1, which is simply 5,400. So this is always visible in my rule that this first number is always the starting out point. What we're starting when we start counting or measuring something, yeah? So this first number right here is your starting out point. And that's always a good number to know. How much did I have to start with? Now let's look how many we have in 1 week. So, and now for W, I'm gonna put 1. So I have 5,400 that I started out with times 3 to the power of 1. And 3 to the power of 1 is simply 3. So it's 5,400 times 3, which is 16,200. Notice how fast these things grow. Now in a week from today, we would have, or we will have 16,200 insects. Do you notice how fast they grow? This growth factor tripling makes it grow really, really fast. Okay. All right, last, going to skip internet traffic. We're going to finches. Finches are birds, and this is another growth problem. A Galapagos cactus finch, so this is a bird population, increases by half every decade. So if it increases by half, my growth factor is 1.5. There's the growth factor, right? Remember up here, the growth factor was 3. See the base here? Yeah, this was my beginning population. This 3 means it's tripling, it's multiplied by 3 each time. But here it's 1.5, so it's 1.5. What do you think the 45 means? It's the beginning when we start counting how many birds do we have? 45 birds, right? So let's look at this. Increases by half, 1.5. The number of finches is modeled, oh, every decade. Look at, that's important, because the time span, look at here, it was weeks. Yep. Insects every week. Now they're talking about a decade. What's a decade? 10 years. Okay, so every decade it grows by half, not doubling. Doubling is different. Yeah, it's growing, but only by half, 1.5. So this is our expression. This is our rule. I can see it's an exponential expression because my variable, d in this case, is an exponent, right? It's raised a little higher. This is the base, 1.5. This is my exponent. And if it's a variable, we can plug in any number we want to find out. First, we need to know what d is. D is the number of decades. Okay, after the population was measured. Evaluate the expression for d, decades, -2, 0, 1. What does each value represent? Again, let's make a t-chart. So my problem says 45 times, I can use parentheses just as well. And my input is the decades and my output is the number of birds. Finches. So they must be very rare. They're probably like almost extinct. And we want to know -2, how long ago was that? 20 years. So 20 years. Why? Because it's decades. 20 years ago. Yeah, because we're going back in time because it's negative. This is now. The most important, what do we start out with? Super important. And then this is in 10 years from now, because a 1 means 1 decade. So this is in the future, because it's +1. So we want to know how many birds were there 20 years ago. We have to plug in for D, -2. So let's write that down. 45 times 1.5 to the power of -2. So our exponent is negative. Do you see it? There it is. Not good. We want to rewrite that as a positive exponent. The 45 does not have a negative exponent. So the 45 is not involved in this operation. Only the power, the base and the exponent go in the bottom of a fraction. So let's multiply 1.5 times 1.5. It's 225, right? So remember, when you have this problem, you can just say 45 divided by 2.25. And when you use your calculator, I get 20. So 20 birds 20 years ago. So 20 years ago, there were 20 of these finches on this island. Galapagos is, by the way, an island. That's where those dragons live, those Komodo dragons, right? So they have a lot of species that are still survived because nobody lives there and nobody can disturb nature. Oh no. I don't want to start interactive mode. Hang on. All right, so 0. That's our starting point. That's now. How many birds do they have now? I already know it's 45 because that's how these rules look, but let's just try it. 45 times 1.5 raised to the power of 0, d is 0. So now this is turning into a 1 because anything to the power of 0 you can replace by 1. 45 times 1 is simply 45. So I already knew that. And then 1, I'm going to plug in 1. 45 times our growth rate or growth factor to the power of 1 is simply 45 times 1.5. And if you use your calculator, you will get 60. Oh, you know what? It's a fraction. It's a decimal, 67.5. Now, we cannot have part of a finch. So should we round up or down? You cannot have a decimal if it's a living being like that. So you can't have part of it. So we need to round. I'll round down just to make it. So there's 67 finches, hopefully in 10 years from now, if this trend continues, that it grows by half. Okay, so that's a prediction. This is from the past, this is now, this is a prediction of your growth for the future. Okay, now we're going to our homework. This is, I think, it for the lesson. And on the homework, we are going to do number 9. So this is on page 288. You're going to do number 9, simplify, meaning you don't want the negative exponent. Look at your examples. Anything to the power of 0 is what? Can we do this? Yes. The only part that needs to be moved is this t, and it goes to the bottom of a fraction. Everything else stays. Yeah, this stays on top. So write a fraction. Whatever is not affected by a negative exponent, leave it on the top. This part needs to go to the bottom. Here, it's the opposite. This part needs to go to the top. Then we're going over to page 289. I want you to do number 17. It's just asking if the answer is positive or negative. So you have to kind of read. So you don't really have to find the answer. They're asking if it's positive or negative. Remember, I talked about parentheses, grouping symbol, make a change in the answer. I can tell you this already, this is negative. But this is not, because you're gonna multiply -2 by itself twice, so it becomes positive. So all of these you're gonna do. And then 21, write each number as a power of 10 using negative exponent. This would be 10 to the power of -1. This would be 10 to the power of -2. And I'm gonna let you figure out 23 and 24. What do you think? Number 25. Complete the pattern using powers of 5. 1 over 5 to the power of 2 is the same as 5 to the power of -2. 1 over 5 to the power of 1 is the same as 5 to the power of -1. I'm going to have you guys finish those. and do B and C. Okay. Number 30 is the word problem I want you to try. This is like the bird population and insect population. You need to study that problem. This one, it's a budget that doubles every year, so you know your growth factor is ×2, yeah? This year's budget is 500. This is your starting point. How much was the club's budget 2 years ago? Right? Make a T-chart like we did. Yeah? So 2 years was -2, 0. What will it be in 1 year? In 2 years? So these would be years, and this would be the budget. And then that's it. That's all we have. Ask me questions in class, okay? Good luck to you.